Hello, everyone. I'm Jichuan Wang, and today I'll present our work accepted at ICCV 2025. The title is Describe, Adapt, and Combine, Empowering Clip Encoders for OpenSet 3D Object Retrieval. Let's get started. First, let's clarify the task we focus on, OpenSet 3D Object Retrieval. Standard 3DOR has overlapping training and test categories. But OpenSet 3DOR is different. It requires models to retrieve 3D objects even when queries belong to unseen categories, which are categories not included in the training set. This is critical for real-world applications like AR/VR and robotics because we can't pre-train on every possible 3D shape. Now, let's talk about the challenges with existing methods. They all have limitations. Multimodal models, such as OpenShape, are computationally heavy. Task-specific designs like HGM2 rely on complex predefined structures. Clip-based zero-shot methods like MV-Clip struggle with the domain gap between natural images and 3D synthetic renderings. Natural images are what Clip uses for pre-training. To address these issues, we propose DSC. It's a three-step framework that is simple, efficient, and only uses multi-view inputs without extra modalities. Let's walk through each step. Step 1 is Describe. We use MLLM, for example in TurnVL, to generate semantic descriptions. These descriptions are for both training and test samples. For training, detailed descriptions help the model capture fine-grained object features. This is much better than using fixed prompts. For testing, these descriptions act as extra semantic cues. They help boost the retrieval of unseen categories. Step 2 is Adapt. Clip is pre-trained on natural images, so we need to adapt it to multi-view 3D inputs. We use a novel method called additive bias LoRa for fine-tuning. Adding an input-independent bias does two things. It helps Clip fit multi-view data, and it reduces overfitting to the training set. Reducing overfitting is critical for open set generalization. Step 3 is Combine. Finally, we fuse two types of features. One is the visual features from Clip's image encoder. The other is the semantic features from the MLLM-generated descriptions. This fusion creates a more discriminative retrieval descriptor. It bridges the gap between visual and semantic information and makes retrieval more accurate. Now, let's dive into the experiments. This is where DAC really shows its strength. We tested it on 4 mainstream OpenSet 3DOR datasets. They are OSESB Core, OSNTU Core, OSMN40 Core, OSABO Core. Across all these datasets, DAC outperforms baselines like Uni3D, HGM2R, and MV-Clip by clear margins. We also have qualitative results. From the retrieval examples, you can see when querying a dresser, Uni3D mixes in TV_stand, and HGM2 returns bed and sofa. But DAC gets all 10 top results right. To sum up, DAC is a simple but powerful framework for OpenSet 3DOR. It is the first to combine generative VLMs like MLLM and discriminative VLMs like Clip for this task. It adapts Clip efficiently with additive bias LoRa and generalizes well to cross-dataset and zero-shot tasks. For more details, you can check our paper on AR14 or our code on GitHub. If you find our work helpful, please cite it. Thank you for your attention.